Okay, let's dive into this. We all know large language models are incredibly powerful, right?
Yeah.
But the big challenge, especially for organizations without huge AI budgets, is tailoring one, making it work for your specific needs, your data.
Exactly. And for a while now, the common approach, the sort of go-to for many smaller projects, has been retrieval augmented generation,
Yeah.
RAG.
Right, RAG is definitely popular. It works by pointing the LLM at your data without actually changing the model itself. But it does make you wonder, are there other ways?
Mm-hmm. Could fine-tuning, maybe full fine-tuning, or perhaps newer techniques like LoRa, actually be practical? Could they be viable alternatives, even for teams with, let's say, more constrained resources?
That's precisely the question we're digging into today. And we're drawing heavily from a really insightful white paper by Skopic. It's called LLM Adaptation Approaches, Analysis of Fine-Tuning Strategies for Medium-Scale Projects.
Yeah, they set out to really test this. They looked at two main paths. First, fully fine-tuning smaller open-source LLMs. And second, using LoRa for fine-tuning medium-sized open-source models. The whole point was to see if either of these could realistically compete with RAG when you're tight on budget, infrastructure, and, well, everything else.
So let's talk about phase one first. That was the full fine-tuning attempt on the smaller models. What was the setup like?
They deliberately kept it accessible. We're talking local, consumer-grade hardware, something like a desktop with maybe 32 gigs of RAM, a couple of 8 GB GPUs, stuff you might actually have.
Okay, so pretty standard gear. What models did they use?
They focused on the FLN T5 family, specifically the base and small versions. The
Yeah.
process involved prepping data, of course. They took about 200 Q&A pairs
Right.
and used commercial LLMs to generate variations, trying to add different contexts to help the model learn beyond just memorizing, then training, then inference, all pretty contained.
And how did that pan out, the results?
Well, the training itself, super fast, like minutes, but the capability of those small models, that was the issue.
Limited.
Very limited. They could learn the facts, sort of parrot them back, but understanding context, producing quality output, that was a real struggle. They basically just overfit the training data almost immediately.
So just memorizing, not really learning to apply the knowledge.
Exactly. The conclusion was pretty clear. For any kind of practical commercial use, these fully fine-tuned small models just weren't cutting it.
Okay, so that leads us to phase two. Trying LoRa with medium-sized LLMs, right? These are models in the, 7 billion parameter range?
Correct. And LoRa, just quickly, is different because you're not retraining the whole model. You train a much smaller adapter layer on top. It's way more resource-friendly.
But even with LoRa being more efficient, that phase one hardware setup, it wasn't enough.
Not even close. For these bigger models, even with LoRa, training would take way too long or just run out of memory. And just running the model for inference was taking like 180 to 300 seconds. Painfully slow.
Wow, okay, so they had to upgrade.
Big time. They shifted to cloud infrastructure. Think powerful GPUs like L40S on platforms like Vast.ai.
And that made a difference.
Huge difference. Immediately, response times plummeted under 10 seconds, much more stable. And suddenly, training was actually feasible. For their 200 Q&A pairs, it took maybe 20 to 60 minutes. Manageable.
So the hardware shift was key. What about the LoRa training itself? Any nuances there?
Yeah, they tweaked things like the adapter rank, the learning rate, which parts of the model to target. But interestingly, the initial results still weren't amazing.
Really? Even with LoRa and better hardware?
Yeah. It came down to the data preparation again. They realized they needed a much more focused data set. Instead of broad context, they created like 20-plus examples just to teach one simple fact, hammering it home from different angles.
Hyper-focused data. And did that work?
It definitely improved things. The LoRa adapted media models were much better than the small ones. Better coherence, better context, they kept their general abilities, and they were more accurate on the specific facts they were trained on.
But not perfect.
Still not perfect. They noted that even with that focused approach, you could still get inconsistencies sometimes. It's not magic.
Okay, so comparing the two approaches directly, LoRa versus full fine-tuning.
LoRa is substantially lighter on resources. Training takes hours, not days. The adapter you save is megabytes, not gigabytes for the whole model. And infrastructure cost is just a fraction compared to full fine-tuning.
But let's talk economics. Even with LoRa self-hosting these models, it's not free, right?
No, definitely not. Their analysis suggests running even a 7D model yourself, even with LoRa, could run you, say, $500 to maybe over $950 a month, depending on your cloud setup and usage.
And how does that stack up against just using commercial APIs, like GPT 3.5 or GPT-4?
Well, for typical usage, something like GPT 3.5 might cost around $140 a month, maybe 2160s for GPT-4, rough estimates, of course. The APIs often give you top-tier performance at a predictable cost.
So self-hosting really only wins out in specific cases.
Pretty much. Strict privacy needs where data can't leave your control. Or if your usage is so massive that API calls become astronomically expensive. Or maybe if you need incredibly deep specialization that APIs just don't offer.
So summing up the key takeaways from Scopic's research.
Data prep is hard, really hard, needs lots of examples, good context. Incremental training seems to help. Small models, they overfit way too easily for this kind of task. And resources, even with LoRA, are still a significant hurdle for self-hosting.
Right. So the bottom line seems to be, RAG is still a very solid, often recommended starting point. LoRA fine-tuning on medium models is possible, and definitely more efficient than full fine-tuning small ones.
But it still requires serious resources, both computational power and, crucially, that careful data preparation effort. It's not a trivial undertaking.
The paper essentially recommends defaulting to commercial APIs, or RAG first, for most projects. Consider fine-tuning even efficient methods like LoRA, only when those approaches fall short and you have the resources and expertise ready.
Exactly. It's reserved for those specific, high-need situations.
Which really leaves this question for you, the listener. Given the significant effort and cost still involved, even with techniques like LoRA, when does that potential payoff from a custom-tuned model truly outweigh the investment compared to just using powerful APIs or setting up a RAG system? Something to think about.
And definitely a big thanks again to Scopic for sharing the research in their white paper. Really valuable insights for anyone navigating these LLM adaptation choices.